Good afternoon, everyone. Today, the topic we're going to talk about is the representation of conceptual knowledge, visual, auditory, and olfactory imagery compared with semantic processing. Have you ever thought about not only visual and auditory, but also your olfactory sensor can help you to build up your conceptual knowledge? Therefore, in the following slides, we are going to show that visual and auditory imaginative processing can be very different from the semantic processing, though both visual and auditory image strongly relies on semantic representations. While on the other hand, there's no difference within the olfactory domain. Speaking of imagery, we human beings have 5 different sensories to create all kinds of memory and imagery. Since the concept of visual is clear enough for everyone, what is auditory? Auditory relies on semantic representation, and by sound plus picture, it creates a possibility for people to judge things faster. Yet on the other hand, the idea of olfactory has long been questioned. Some scholars found out that verbal encoding of odor enhanced the olfactory long-term retention. Yet in the real perception, imagery of a pleasant odors generally involves longer sniffs, which means it's much easier for someone to remember the smell of a pile of garbage instead of an odor of a nice perfume. On the other side, perception is a process by which individuals organize and interpret their sensory impressions in order to give the meaning of their environment, such as the picture. One say the label is 6, while the other one considered it's a 9. Above all, we know that these two share the common mechanism and process. Recently, it has been found out that there is overlap between the visual perception and the visual imagery. Take myopia and astigmatism as an example. The blurry conception will easily lead to a weak mental image. Therefore, the external world may also adjust and change by the visual image. The following we are going to talk about 2 theories. The first one, propositional theories, assume that we people do not store mental representations in forms of images or mere words. Dr. Palmiero argues that mental images are neither spatial nor depictive in nature for different empirical reasons, such as the use of tacit knowledge to stimulate the relevant phenomenon. On the other hand, we can only experience our mental representation, and the symbolic language-like system is used to represent the information. This picture is a classic image of the propositional theories. Whether it's a rabbit or a duck, people have different kinds of opinions, yet they have a hard time to find more than one interpretation to explain why such figures have this kind of perceptual cognition, because basically it's just a temporary image, especially mental image in their mind. Secondly, the whole of the 2 combined images are different from the sum of its 2 distinct parts. It means that because of the special design of the sketch has been conducted in order to make the picture look like a rabbit and a duck at the same time. The second theory is dual coding theory. According to dual code theory, we use both pictorial and verbal codes for representing information in our minds, which means language conveying symbolic representations, while verbal imagery allowing analogical representations. The above have cortical overlap according to different reasons, and so the interaction exists between these systems, since a verbal description can be generated from a mental image, or a mental image, we say, can be generated from a verbal description too. According to Dr. Colesling, visual image is generated from a semantic representation, and this semantic representation stores visual information, which is also a coordinate space that contemporarily maintains and manipulates information in a place located into so-called visual buffer. Last but not least, everything we sense will be stored in our brain area. So the purpose of the study is to investigate how people represent conceptual knowledge, especially comparing visual, auditory, and olfactory imagery with semantic-based representations. Thus, the study carried through 2 experiments with 2 hypotheses. First, Knowledge is proceeded according to imagery modality-specific principles, and mental image-based represents are differentiated from semantic-based represents in terms of response times or accuracy. Second, knowledge relies mostly on semantic system, being organized according to more general principles, and mental image-based represents are not differentiated from semantic-based represents both in terms of response times and accuracy.
Okay, let's get to experiment 1. There were 87 participants who were voluntary basis and mostly from the Department of Psychology at this school in Italy. Material were 48 triplets of items. The target items share sensory properties with one of the two comparison items, and semantic properties with the other one. So triplets included both imaginative comparisons and semantic comparisons. Procedure. The first one was the instruction, then the target word was displayed. Participants form an image or a semantic representation, which means category, and then press the spacebar, and two comparison words were presented simultaneously. Then follow the instruction to choose the right answer by pressing the right word or the left word arrow key as quickly and accurately as possible. This experiment lasted about 20 minutes. The parameters. GTs were measured from the time of target item on set until the spacebar was pressed. RTs were estimated from the comparison items on set until the right word or the left word arrow key was pressed. Let's demonstrate the experiment. First one, instruction. So here we have to focus on the shape of the falling item. Then the target item is umbrella. So we imagine the shape of it. And then press the spacebar. So here are two comparison items. We need to press the right word arrow key for the correct answer. That's how experiment 1 works. Here comes the results. The analysis on GTs shows that participants generated different mental representations at the same speed, regardless of the type of processing. The analysis on RTs shows that within the visual and auditory modalities, mental images were processed more slowly than semantic representations. No difference was found within the olfactory modality, both in terms of RTs and accuracy. Experiment 2 was designed as experiment 1 in order to evaluate the effects of processing and modality on RTs and accuracy. Stimuli were composed of pairs of items instead of triplets because the lack of comparable items, especially in the auditory and olfactory imagery modalities. The true pairs included items from the same category and with no similarity in terms of sensory properties, whereas the false pairs included items from different categories and with similarity in terms of sensory properties. Results. The analysis of RTs shows that in all modalities, mental images were processed at the same speed as semantic representations. In addition, visual images were processed with higher accuracy than semantic representations, whereas the processing of auditory and olfactory images were as accurate as semantic representations. General discussion. Through these two experiments, we can prove for the first time that mental images and semantic representations cannot be equally distinguished in all sensory modalities. Indeed, when images to be compared were generated from different categories, as experiment 1, differences between the imaginative processing and the semantic processing were found within the visual modality in RTs and within the auditory modality in RTs and accuracy. However, when images to be compared were generated from the same categories as the experiment 2, visual imagery was performed at the same speed and even with better accuracy of semantic representations. The match between the semantic representations of the comparison words and semantic representation of the target words improved imaginative processing. Our 5 senses may affect our teaching or learning. For example, when teaching Chinese tea culture, smell and taste are very important. I wonder if you have any experience in teaching or learning with 5 senses. Taking myself as an example, I had to memorize a poem named 短歌行, but it wasn't short at all. So I searched on YouTube for a song which was composed of 短歌行 as lyrics. That really helped me to memorize it correctly. This may be an example of auditory learning. Here are a few questions for everyone. Please write down your answer on Moodle. Thanks for listening.